Find the limit as x approaches 1 of x squared minus 7x plus 6 all over negative 8x plus 8. So normally, if a function is continuous, I can just plug in this value and then simplify to find the limit. If it's a continuous function and if the function actually exists at that point. However, we notice that at 1, when I plug in 1 to the denominator here, I'll get negative 8 plus positive 8, which will equal 0. And I'll get whatever the numerator is divided by 0. So I'm going to get some number up there divided by 0, and then this is going to all be undefined. And we would normally say, hey, the limit does not exist because it's undefined or whatnot, but we would be wrong. Because in this case, we need to figure out, is there actually a factor that cancels here? And then maybe we can find a limit. And that's actually the case in this situation. So I'm going to factor the numerator and denominator. Factoring the numerator, I'm going to use the x method. Because the coefficient here is 1 on the x squared term, all I have to do is find two numbers that multiply to be 6 and add to negative 7. So what numbers multiply to 6? I'm thinking 2 and 3, but they don't add to 7. They would add to 5 possibly, but not 7. And what about 1 and 6? Those do add to 7, but if they make them negative, then they'll add to negative 7. So now negative 1 and positive 6, sorry, negative 1 and negative 6 do multiply to be positive 6, and they do add to negative 7. So I do know that this can factor into x. Sorry, I'll write it up here. It can factor into x minus 1 and x minus 6. Now the bottom is just simply it's a binomial, meaning there's two terms being added together. This was a trinomial in the numerator, and that we usually use like the x method or other factoring to factor something like that. But this is a binomial. So really the only thing we can do is it's possibly a difference of squares, which is not the case. Or we have a common factor that we can factor out. So in other words, numerator and the negative 8x and 8x have something in common that divides both of them. So here's an easier example. Maybe if I have 25x, so I'm just going to do a totally different example for a second here. If I have 25x plus 5, I'm trying to factor, which I'm trying to find two things that multiply and make that answer. So I notice that I can divide 25 by 5, and I can divide 5 by 5. So I pull a 5 out to the front. And then I know that to make something like this, I must have taken a 5 and multiplied by some kind of binomial. So 5 times what equals 25? Well, 5x. Then 5 times what equals 5? Plus 1. So you can see that if I multiply this expression out, 5 times 5x, I'll get 25x. And if I do 5 times 1, I'll get 5. And so this will multiply out to be this. So I'm going to do the same thing here. I'm going to find the number and the binomial that multiply together to be this. So what do I see that divides the numerator, or I'm sorry, the first term and the second term? That's the common factor. And I see an 8. I'm actually going to take out a negative 8. I don't have to, but Usually when I have a coefficient, a negative coefficient, I don't like having a negative coefficient, so I'm going to take that out by factoring out a -8. Then that leaves me, okay, then I have two terms in here. So -8 times what gives me -8? 8x. Well, x. Then -8 times what gives me +8? -1. So I believe that -8x plus 8 can factor into -8 times x minus 1. Let's see if that multiplies out. -8 times +x equals -8x. -8 times -1 equals +8. So this does multiply out. So I did factor that correctly. I did put at the bottom of 8.3 of 4.3, there are more videos like going over how to factor expressions like this. So next, I noticed that there's a common factor in the numerator and denominator. And actually, we're actually dividing the numerator and denominator by this term. To divide the numerator by x minus 1 and divide the denominator by x minus 1. Because we are multiplying by those terms, dividing by that term is the same as just canceling out a factor and a factor. So technically, if I was left with no factors left in the numerator, there would be still always a 1 left in the numerator. And the same thing with the denominator. If all the factors canceled, I would always be left with a 1 in the denominator. But what's left here is x minus 6 over -8. Now, as you've noticed, if we calculate the limit as x approaches 1 of this simplified version, now I no longer have a problem with, I can now plug in the 1 into this equation and it's not going to give me an undefined response. What that's telling me is there was a hole in the graph, a lot like this. There's a hole in the graph where x equals 1. Now, if at this moment I still had a hole in the bottom, even after I simplified, then it would mean that I have I believe it's a vertical asymptote at 1. Yes. So if it still had, when we plug in 1 right here, if it still had a 0, if 1 made the denominator 0, then we would know that there's a vertical asymptote at 1. In that case, when we approach 1, the graph, when we approach 1, would be going it would be going like this. So it probably, from one side, it'd probably be approaching -infinity, and the other side would approach positive infinity. I'm not sure which one would be which, but it would be something like that. We'd have a vertical asymptote of some sort happening at 1 if 1 still made the denominator 0. So there you go. But here we know, since this factor canceled out and now there's no longer, when we plug in 1, it no longer makes it 0. We know that this is a hole in the graph. So it looks like the one above here, the picture. So to solve this from here, this is now a continuous function at 1. So we just can plug 1 into the equation to find the limit. So 1 minus 6. So it becomes -5 over -8, which implies to be +5/8. And there we go, 5/8. I don't know why I wrote 6.